Preventing earthquakes. In 1556, a catastrophic event hit China, the worst earthquake that humankind has ever seen, with 830,000 casualties. During those times, humans did not know what an earthquake was. Humans probably thought it was a punishment from the gods. Most of the deaths happened because during those times people lived in caves, which caved in during the earthquake. Another earthquake that impacted society was the North Ridge. The National Aeronautics and Space Administration, known as NASA, announced that the Northridge earthquake, which happened in 1994, was a modest magnitude of 6.7 event which caused 57 deaths and over $20 billion of damage and created major disruption of Los Angeles area infrastructure. NASA also looked at Kobe. Kobe was an earthquake with a magnitude of 6.9 and led to 5,480 deaths and damages of $150 billion, which impacted Japan and the whole world. Events like this show humans to be aware about earthquakes. Earthquakes have a powerful effect on society because they destroy everything, including human lives. An effect of an earthquake can be so powerful that it can change the speed of the earth. According to Astrobiology magazine, the magnitude 8.9 earthquake in Japan was a result of thrust faulting between the Pacific and the North American plates. Shift of mass made the Earth's rotation speed up by 1.6 microseconds. It is important to be alarmed about earthquakes, as human activity can cause earthquakes. In the Kingdom, a multi-purpose stadium in Seattle was blown up. It created an earthquake of magnitude 2.3, says USGS.gov. That is why it is important to be informed and know what earthquakes happen and learn what they are capable of. That way precautions can be made to ensure safety. National Geographic teaches about the different levels of magnitude. National Geographic stated that quakes measuring 3 to 5 are minor, 5 to 7 are moderate, strong, 7 to 8 are major, 8 and more is greater. Earthquakes happen every single day. Most of them are minor earthquakes. Although strong quakes are still around, National Geographic stated that a magnitude 8 earthquake happens somewhere every year and kills about 10,000 people. Most deaths are due to collapsing buildings. National Geographic also stated that about 80% of all earthquakes happen in the Pacific Ocean, a place known as the Ring of Fire. Earthquakes happen when energy is released and seismic waves make the ground shake, which causes secondary effects. Earthquakes have secondary effects, which are more deadly than the earthquake itself. The secondary effects of an earthquake can be tsunamis, landslides, liquefactions, and fires. Tsunamis are the most common effect. A tsunami happens when an earthquake takes place underwater, creating a large wave. According to Astrobiology magazine, an earthquake near the coast of Japan created a tsunami that devastated a city of about 1 million residents. Common places where tsunami is more likely to occur are in Peru, Chile, Indonesia, Papua New Guinea, Vanuatu, and the Solomon Islands. Liquefaction in the soil can cause buildings to collapse at a higher rate. USGS.gov stated that in 1985 in Mexico City, buildings collapsed due to wet sand in the foundation, which ended up killing 10,000 people. In the US, the worst earthquake happened in San Francisco in 1906, killing about 3,000 people as a result of fire. The webpage USGS.gov stated that out of the earthquakes recorded since 1968, the secondary effects of earthquake have been 9 fires, 276 landslides, 24 liquefactions, and 298 tsunamis. Also, 21% of fatal earthquakes have been because of secondary causes. As seen, secondary effects of an earthquake have let society know what they are capable of. As humans develop in technology, a demand towards public safety is needed. The Solid Earth Science Group, known as the
SESWG is working on things to help minimize the earthquake's damage. The SESWG is looking into characterize of motions of the Earth's surface globally, understand fault system interaction and stress transfer physics, and model and predict the behaviors of earthquake systems. If SESWG accomplishes their goals, then society is a step closer to benefit from preventing earthquakes or at least their damages. If SESWG is able to do what they have said to do, then the fruits of the labor will be favorable to society since they would be able to identify and validate possible local and regional precursors to earthquakes, refine global maps and natural hazards to support mitigation strategies, and enable rapid responses to seismic disaster worldwide. Another very important ingredient in order to reduce this global issue falls under the hands of engineers. Engineers play an important role because it is up to them to have the creativity that will prevent buildings from turning into dust as an earthquake collapses them. Buildings or structures built with materials such as brick, stone, or concrete that is not flexible can easily collapse when shaken. These are the worst types of structures. When constructing buildings, brittle elements will break over elements that are ductile. Buildings likely to survive an earthquake are low wooden structures anchored to their foundations and wrapped around with thick plywood. Unfortunately, structures like these will be used on a home, not on a big building. Another downside to constructing a structure like this is that wood and plywood have a high rate of catching on fire, and with fire being a secondary effect of an earthquake, that might not be a good idea. Multidisciplinary Center for Earthquake Engineering Research, also known as the MCEER, stated that engineers focus on researching performance-based design, development for damage-resistant systems, and improvement in the ability to predict the occurrence and intensity of earthquakes. According to MCEER, when engineers design buildings strong enough to prevent earthquakes, they use certain methods such as shear wall, brace frames, moving resistant frames, diaphragms, due system, pile foundations, cantilever columns, and isolation and horizontal truss. Thanks to MCEER, the following types of methods have been provided. Shear walls are vertical walls that are designed to receive lateral force from diaphragms and transmit them to the ground. Damping devices and bracing systems are damper brace arrangement, with one end attached to a column and one end attached to the flood beam, which prevents building from falling. Movement resistant frames are rectilinear assemblies of beams and columns with beams rigidly connected to the column. Diaphragms are used to take the force that is going horizontally and pushes it vertically. A due system is a combination of movement frames and brace frames or shear walls. Pile foundations can prevent buildings from falling because the piles go past the liquefaction zone. Cantilever columns rely on the cantilever strength and stiffness of columns restrained against rotation at their bases. Isolation is a base isolated structure that is supported by a series of bearing pads which are placed between the buildings and the building's foundation. Also, a spherical sliding isolation is used when buildings are supported by bearing pads that have curved surface and low friction. During an earthquake, the buildings are free to slide on the bearings. Since the bearings have a curved surface, the building slides both horizontally and vertically.
All of the methods that have been listed have one purpose only, and it is to prevent earthquakes. And they do that by taking the vibrations and damping them instead of amplifying the vibrations. These methods let the buildings be damaged but prevent the buildings from falling, which results in the safety of the people. Although there are buildings that have to withstand earthquakes, such as hospitals, fire stations, emergency communications, and the rest of structures that must be ready to provide help to society. Thanks to engineers and construction workers, earthquakes are not as deadly. In the US, only 5 earthquakes have killed more than 60 people since 1950. as seeing all the hard effort is paying off. Society is starting to see the fruit of the labor. It is a hard fight when it is against Mother Nature, but with dedication and endless effort, progress has been made. It is important to keep in mind the dangers of earthquakes and its secondary effects, as it may lead in catastrophic results like destruction and, worst of all, death. Death should be the number one priority in this fight. Life is way too precious to let it be taken by large quantity when something can be done. The first step is to identify earthquakes. Know the signs before it's too late. If that can be done, then people can be aware and ready to embrace them. The second step is to construct buildings that can withstand earthquakes. This is a big step because nobody knows when or where an earthquake will take place. It is also a hard step because of the economic reasons. Not all countries will have the luxury to provide buildings strong enough to withstand earthquakes. The construction of the buildings will also take longer due to adding extra steps to ensure the safety of the people. The third step falls upon society as a whole, and that is to support and demand that all buildings are constructed with methods to provide safety against earthquakes. If society joins as one voice to let the world hear that this is a global issue and that needs to be dealt with, the steps will be taken to provide once and for all the necessary requirements to ensure safety. Thanks to USGS.gov, National Geographic, Astrobiology Magazine, NASA, and the SESWG for supporting the prevention of earthquakes and letting society know that this is a global issue that needs to be dealt with. These organizations have been very helpful in supporting to prevent Mother Nature to strike with a force that leaves the world at shock. Please do not let Haiti 2010 repeat again. Let that earthquake be the earthquake of the century. Do not take Mother Nature lightly, because when it strikes, it will leave a scar if no precautions are made.